percentage. Percentage is used in everyday life to measure different quantities. A good way to understand percent is by thinking about your phone battery. If battery's capacity, or how long you can use it for, is measured in milliamp hours. The iPhone 11 has official battery capacity of 3,110 milliamp hour. That means when your battery is 100% or completely charged, it holds 3,110 milliamp hour. Now let's just say as the day progresses and you're using your phone, when your battery is at 50%, that means it is actually holding 1,555 milliamp hour. Now what if you have used it all day? By the end of the day, you're at 10%. At that point, your battery holds 311 milliamp hour of charge. Now, if you don't understand this analogy completely, you should continue listening, as things will become clearer by the end of this video. There is a reason phone designers show battery charge as percentage, so it is clear to the user and everyday person, and they can understand the quantity value assigned to the phone charge instead of something like 1,674 milliamp hour showing up on the right top corner of your phone. The word percent literally means out of 100. It helps to keep this in mind as you're solving various problems, because when you keep that in mind, it will allow you to look at percentage through different perspectives, and that can help you break down the information while you are doing a word problem. Now let's consider this word problem. There are 40 animals in a zoo, and out of them, 30% are reptiles. How many reptiles are in the zoo? Essentially, our problem is that there are 40 animals in the zoo, and 30% of those 40 animals are reptile. So we need to find out 30% of 40. Earlier we said percent literally means out of 100. In math, off, the word off is used instead of multiplying or product. So when you see this word problem and your math problem boils down to essentially finding 30% of 40, you should interpret this as 30 out of 100, because that's what percent means, times, that's what off means, 40. So your math problem becomes 30 out of 100 times 40. Now, whenever I'm doing multiplication of fractions, I like to write whole numbers as a fraction. Even though I know there is a hidden one and I don't necessarily have to, I'd like to do it so that I'm just 100% crystal clear on all of my calculations. So when I write the product, I'm going to multiply the numerator with the numerator, 30 times 40, and the denominator times denominator, 100 times 1. On the numerator, we get 30 times 40, 1,200. On the denominator, we get 100. If you simplify them, divide them, you get 12, which means that there are 12 reptiles in the zoo. 30% of 40 is 12. Now let's discuss a couple of more percentage scenarios. Let's start off with 10%. What does 10% mean? I want you guys to get comfortable using the language, and as soon as you use it, I want you to have a clear picture mentally what it means. 10% means 10 out of 100. Now 10 out of 100, if I simplify it, I can turn it into 1/10. So 10% or 1/10 is the same thing. So me saying 10% of my classmates are left-handed versus me saying 1/10 of my classmates are left-handed, they're essentially the same value. 20% means 20 out of 100. 20 out of 100 means 1/5, because if I simplify 20 over 100, that's what I get. 25% is 25 out of 100. 25 out of 100 simplified. If I divide both numerator and denominator by 5, I start 5 divided by 25 is 5. 100 divided by 5 is 4. I simplified one more round, divide both 5 and 20 by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. 1/4. 50% means 50 out of 100. Again, if I simplify it, I get half. So saying 50% discount or half off, they're both essentially the same thing. Now, what about 75%? What do you think 75% means? I would like to give you guys a couple of seconds to see if you can figure out mentally 75% would be equal to what fraction? 75 out of 100. If I simplify it, I'm going to end up with 3/4. So if you said 3/4, you are on the right track. If you're looking at a standard soda can, it holds about 12 fluid ounces or 355 milliliters of fluid. Now that comes out to about 1/3 of a liter. There are two scenarios here, and the scenario on the left is basically asking, what if the soda can is 25% full, then how much liquid should be there if it is 25% full? Now we know from our earlier calculations that 25% is equivalent to 1/4. Therefore, I need to find out what is 25% of 12 fluid ounces or 1/4 of 12 fluid ounces. Now, if I did the math, either way, I would end up with the same answer, which is 3. So when it's 1/4 full, it has 3 fluid ounces of liquid in it. Now let's consider the scenario to the right, which states that what if it is 80% full? If it is 80% full, which means that 80 out of 100, which if you start simplifying with 20, you get 4 on the numerator, 5 in the denominator, which eventually ends up giving you 4/5. Now, my calculation should be 80% of 12. Again, 80% means 80 out of 100. Off means times 12 over 1. Remember, we earlier discussed that whenever we have a whole number, we should write it as a fraction, such as here 12 over 1, just to avoid any kind of calculation mistakes. 80 times 12 is 960, 100 times 1 is 100. So when we divide them, we get 96 over 10, or 9.6 fluid ounces. Now remember, 80% can also be interpreted as 4/5. So I could have also found what is 4/5 of 12. Now, if I want to find out what's 4/5 of 12, 4/5 times 12 over 1 gives me 48 over 5, which again, if I were to divide it, I get 9.6, or if I were to leave it as a fraction, I would get 9 3/5 fluid ounces. Now, the next question is, what if this can was 100% full? Then how much soda would there be? If you said 12 ounces, your answer would be 100% correct. Now, what if the question was, how much soda should there be in the container when it is 110% full? If you had a couple of seconds to think about it, what you should realize is that 110% means that it's going to be more than 12 fluid ounces or 355 milliliter, and the full capacity of this can is 12 fluid ounces. Therefore, if there's anything more than 12, it's going to basically spill out of the container, and therefore this can hypothetically cannot hold 110% capacity. Let's consider another word problem to better understand percentage. Let's say there are 70 students in a classroom. Out of these students, 30% are sophomores, 40% are juniors, and the rest are seniors. Now the question is, how many of these students are sophomores? How many of these students are juniors? And how many of these students are seniors? Now the first thing we should notice is that the total number of students is 70. Therefore, 100% or full capacity is equal to 70. Now the first thing we need to do is find the number of sophomores. Since there are 30% sophomores, the math problem becomes 30% of 70. Utilizing what we have learned earlier, we know that 30% translates to 30 over 100 times 70 over 1, which gives us 2,100 over 100 simplified 21. That means out of the 70 students, 21 are sophomores. Now the number of juniors, there are 40% of the class is juniors. So 40% of 70 roughly translates to 40 over 100 times 70 over 1, which gives us 2,800 over 100 simplified to 28. So 40% of 70 is 28. That means there are 28 juniors. Now, how about the seniors? If we add the number of sophomores and we add the number of juniors, 21 plus 28 gives us 49, and we subtract that from 70, we get 21, which means there are 21 seniors. Now, what if the question also asked what percent of the class is seniors? Do we need to do any of this math in order to figure that out? No. As long as they told us that all of the 70 students are only sophomores, juniors, and seniors, that there are no freshmen there. If that was made clear, that the class of 70 students is made up of sophomores, juniors, and seniors, then we know that 30 plus 40 is 70 and 100% is full capacity, which means that the number of seniors would be 30%. So we wouldn't need to do any of this math in order to figure that out. Also, if the question was, well, how many seniors are there? We already know 30% of 70 is 21, so there would be 21. Percent can be used to describe a range of data, from the amount of charge left on your phone to describing how much of the population in New York City is teenagers, and to how much soda is left in the can. Although I doubt you will hear anyone yell out at a barbecue, "We only have 40% soda left, get some more now." Percent can be interpreted as a fraction and also as a decimal. Understanding how to convert percent to decimals and fractions, and being able to use that data to solve word problems is a very important and necessary skill set for most middle school students, as you guys will be dealing with a tremendous amount of percentage ratio problems. I hope you guys learned something new today, and if percent wasn't clear earlier, that after this video it was at least slightly clearer. And I will be posting more videos for percent and probability, so if you guys have any other questions, feel free to ask in the comments.